What's up, guys? Clayton Buckwater here. I have fat, you have fat, everybody that is alive on this earth has fat. But when you lose your body fat, where does it go? You can't take something with mass and pounds, your body fat, and just turn it into nothing. It can't just disappear. So where does it go whenever you're burning body fat? Let's figure out. Your body stores fat as triglycerides. These are the fat cells that you see in the adipose tissue around your stomach and your hips. These are three long fatty acid chains attached to a glycerol molecule. The first thing that happens is a process called lipolysis. This happens inside of the cytoplasm of your cell, and it breaks apart the glycerol molecules from the free fatty acids. We're going to focus on the free fatty acid portion because those are your fat molecules. Boom! Then they get beta oxidized. The free fatty acids go through a process called beta oxidization, which turns them into a free fatty acid version of acetyl-CoA. Acetyl-CoA can then get transferred inside of your mitochondria, which everybody knows is the powerhouse of the cell where energy is created. It enters right into the Krebs cycle, where a whole bunch of chemical reactions, enzymes, and transferring of electrons take place, which then turns it into, boom, adenosine triphosphate, ATP. Boom, ATP. Now, I'm not saying this is exactly what an ATP molecule looks like, but it's pretty darn close to the real thing. So you have an adenine group and a ribose group. Those, no one couldn't care less about those. They're not important. The very important thing are the three phosphate groups sitting over here on this side. Through a process called hydrolysis, which is just a very, very fancy word to make me sound smart, which just means add water to it, the phosphate group goes bye-bye and it falls off. It gets attached to a different molecule called phosphorylation is that process. That's what gives you the energy. The breaking of this chemical bond between the phosphate groups is what gives you energy, not the breaking down of atoms. So this doesn't explain at all where our fat goes to after we lose it. So now that we know triglycerides breaking down into energy doesn't explain where the mass of the fat goes to, because it's the breaking of chemical bonds that gives us the energy from ATP, not the breaking down of the actual fat molecules themselves, of the mass of the carbon, the hydrogen, and the oxygen that it's made of. So let's do a little bit of chemistry to figure out where it goes. Alright, so who recognizes this molecule? Anybody out there? Anybody? No? No? Alright. This is the most common fat molecule in your body. Now there are other ones with different amounts of carbon and hydrogen, but across the board this is the most common one. So this is the one we're going to look at and try to figure out the breakdown of it. The process of getting energy out of your fat molecule, the C55H1O4O6, that we just talked about is called the aerobic energy system because it needs oxygen to function. So you have to add oxygen to this side of the equation to get the breakdown of the fat molecule. After you add oxygen to it, we can figure out the other side of the equation, and you get carbon dioxide, water, and energy are the three byproducts of this chemical reaction. So now we just gotta take a second and balance out the carbons and oxygens, and I'll be right back in just a second here. So now that it's all balanced out, we can look at this equation and see. You start with two masses, you end with two masses. You get mass, you get mass, you get mass, you get mass. And we also end up with energy from calories from the breaking of that ATP. So this is where your fat goes to. Carbon dioxide and water. We did it! Up top! Now that we know that carbon dioxide and water are the two mass having weight byproducts of your fat, let's figure out how much of your fat leaves your body as those two things. Now how do we do that? Now I know what you're thinking. You're sitting there going, this is level 1 chemistry! This is so easy! all you have to do is take the atomic mass units of carbon, hydrogen, and oxygen and multiply them by how many are in that molecule to get the molecular weight of that atom. And then you're going to take 2 oxygens and pair them with a carbon, 1 oxygen and pair them with a hydrogen, because that's what you get on the other side of the equation. After you do that, add the weight of the oxygens to the carbon and add the weight of the oxygens to the hydrogen. Then you're going to take that weight that you just got, divide it out from the total weight of that molecule, and you get the percentages of what comes out on the other side. Duh! Alright, let's do what you guys say to do. You're going to take the 55 carbon, multiply it by 12, 104, multiply it by 1, and the 6 oxygen, multiply it by 15.9. You're going to get a total number of 861.41. That is the total weight of a triglyceride of fat in atomic mass units. We're going to take that 2-to-1 ratio that we very quickly breezed over in the last segment. We're going to put 4 oxygens with a carbon, 2 oxygens with a hydrogen, add that to the atomic weight, divide it by the total, and you end up getting 84% of your body fat leaves you as carbon dioxide. 16% leaves you as water. Just think about that for a second. 84% of the fat that you lose comes out in carbon dioxide. That's pretty interesting. So naturally, you're just sitting there thinking, can I just breathe more? If 84% of my body fat comes out as carbon dioxide, if I just sit there and breathe as fast as I can, am I going to lose body fat? You can just breathe more, but it will not help you lose body fat. Your body needs a reason to break down those triglycerides. If you're not eating a healthy diet and exercising regularly and giving your body the need for the calories and the need for the energy of your body fat, it's not just going to break down. If you just sit there and hyperventilate all day long, you're just going to pass out a whole bunch more and be the exact same body weight. Thank you for watching my video. If you're interested in nutritional advice, exercise advice, and just science of the human body, please subscribe to my channel. Or if you're just someone that likes to subscribe to channels, so they can say I subscribe to this channel, you could subscribe then too.